Lesson 1-4, Velocity versus Time Graphs. Acceleration is the rate of change of velocity. In other words, it is how quickly the velocity is changing. For a graph like this, if we were to find how quickly the velocity is changing, that would be the slope, because remember, slope is the rate of change. So it would be the slope of a velocity versus time graph. Now it turns out that displacement can be found from a velocity versus time graph because it'll be the area between the graph and the t-axis of a velocity versus time graph. So if I wanted the displacement from 0 to 10, I would find that area, and that would be the displacement. Let's calculate the displacement over 30 seconds. So for displacement, I want the area. So maybe I could divide my area into these two parts. So I'll have this triangle and this rectangle. So let's start with the triangle. Triangle area is 1/2 base times height. The base, the distance across the bottom here, is 30 seconds. And the height is, well, let's see, this point looks like it is 30,165. And this point here, let's say, is about 0.15. So my height would be 165 meters per second minus 15 meters per second, which should give us half of 30 times 150, which is 2,250 meters. For the rectangle on the bottom, the area is just base times height, so that is 30 seconds. And the height of the rectangle would be from 0 to 15, so that would be 15 meters per second. You multiply those, and you get 450 meters. So then you total, and it looks like our total displacement is 2,700 meters over the 30 seconds. Part B, find the acceleration over the 30 seconds. Since this is a straight line, we just need the slope. So we're going to look for the slope. So that would be y2 minus y1 over x2 minus x1, or 150 meters per second over 30 seconds, or 50 meters per second squared. Sorry, it's not 50, it is 5.0 meters per second squared. That means that every second, the velocity is changing by 5 meters per second. What's the instantaneous velocity? Well, instantaneous velocity we can read from our graph at 20 seconds. That's right there. So that's approximately 120 meters per second. And then the average velocity. Well, the velocity keeps changing, so the average, what I'm going to do is I'm going to add the initial and the final, because it's a straight line in between. And then if I divide by 2, that's how you find an average, right? Add the numbers and divide by the number of numbers to get 90 meters per second on average. Now our graph is curved. Let's see, how would you do this that way? Find the displacement over the first 20 seconds. All right, so let's draw it. So there's 20. There's 10. So we've got a triangle approximately up there, a rectangle, another triangle approximately, and another rectangle. So let's start by calling this one triangle 1. 1/2 base times height. Oh, looks like I need some coordinates here. Let's say this one is 0, 165. So our base is 10 seconds, and the height is from 210 to 165. So 210 meters per second minus 165 meters per second equals 225 meters. Let's do the other triangle. Triangle 2. The base again is 10 seconds. Now our height is, let's see, what's that point? That point looks like it is 230. So its height would be 230 minus 210, which gives us 100 meters. Now let's do this rectangle. Now, the bottom part of the graph is cut off, so our height is going to be kind of funny. So our base is 10 seconds wide, but the height goes from 0 to 165. So the bottom of the graph is missing. So it gives us 1,650 meters. And then rectangle 4 there, base times height. Base is 10 seconds. The height is up to there, which is 210. Gives us 2,100 meters. So our total displacement, add those up. 225 plus 100 plus 1,650 plus 2,100 gives me 4,075 meters, which would probably say rounds to about 4,100 meters, because we had to do some estimating. Let's find the instantaneous acceleration at 30 seconds. Now to do that, we had to draw a tangent line. That tangent line you see is already drawn. So I need to find the slope of the tangent line. So I have 2 points on this tangent line, 0 and 210. And that one up there is 50 and 260. So I'm going to use the slope, so it's y2 minus y1 over x2 minus x1. So that'll be 50 meters per second over 50 seconds, or 1 meter per second squared, which means on average, at 30 seconds, the velocity is changing by 1 meter per second every second.